is Ethernet, what is wired LAN, what is standard Ethernet, what are the types of Ethernet. So in today's class, I'll basically discuss what is the implementation types of standard Ethernet. So if you please go through that video first, standard Ethernet, and then please watch this. What is implementation in standard Ethernet? So many times in many where you seen this kind of 10 ways something, likewise representation is there. So many times you have maybe asked the question, ma'am, what is this 10 base x or 10 base 5, 10 base t, 10 base f, right? So today I'll clear that doubt. So whenever first 10, what is this 10 will represent? 10 Mbps, because till now we are discussing standard Ethernet. So speed of standard Ethernet is 10 Mbps. After that, base will represent baseband, means digital communication. Whenever we are dealing with digital, at that time we are calling as a baseband, right? And what is this x will represent? Means x can be anything. X can be t, x can be phi, x can be to anything, right? So normally this x will what, maximum size of the cable is 100 meter, means let's say they have given 10 base phi, then simply I have to multiply this phi with 100. So it is that range of that particular standard Ethernet is 500 meter. So now let us start with what are the types of this standard Ethernet, how they are implemented, what kind of cables they are using, everything I'll discuss. So this is a basic overview of all implementation, right? So basically four types are there. First one is 10 base 5, 10 base 2, 10 base T, and 10 base F. Now what are the medium used during this implementation? First one is thick coax. Coax means what? Coaxial cable, right? So thick coaxial cable, thin coaxial cable, 2 UTP. UTP means what? Unshielded twisted pair, right? Twisted pair cable we are using during our connection, right? And two fiber. Fiber means what? We are using optical fiber. Now, medium length. I already discussed this is x, right? We are assuming that this is x. If it is 5, then simply I have to multiply with 100. So this is 500. If it is 2, simply I am multiplying with, it should be 200, but minimum is 185. What is this 10 base T? T means what? Whenever T is there in any kind of Ethernet, then simply we have to assume that it is unshielded twisted pair cable, right? And length of or medium length is 100 meter. And last one is 10 base F. F means what? It is used for fiber or optical fiber, and maximum medium length is 2000 meter. So it is the highest medium length, right? And what are the encoding that is used during this implementation? For all, we are using Manchester encoding. What is Manchester encoding? We already discussed during module 2, right? How, what is Manchester, differential Manchester, NRZ, NRZI, NRZL, so many other encoding also we discussed there. So from that Manchester encoding we are using during this Ethernet. So T means I already discussed, it is unshielded twisted pair cable, and F means fiber optic. So one by one also I'll discuss uh, in detail. First one is 10 base 5. So many times we can call as thick Ethernet, or in short form they'll call thicknet. Whenever we are dealing with thick Ethernet, bus topology is used. Mostly we are using bus topology. In higher Ethernet, let's say 10 base T, 10 base F, we are dealing with star topology or switches, different things we are using. So this is very basic one. For 500 meter only we are designing, so for that we are using bus topology only. So speed is 10 Mbps, baseband 500 meter, as the name suggests, 10 base 5, 10 Mbps, baseband, and 500 meter. In this, transceiver is used. Transceiver is simply a transmitter or receiver. In exam, many times they'll mention these kind of words. So it is a receiver, you all know, or transmitter means sender, right? So these two are transceiver. Uh, it is transceiver means what? either sender or receiver. Transceiver's responsibility is transmitting the data, receiving the data, and detecting the collision during this 10 base 5 thick Ethernet protocol. And coaxial cable is used as a part of this thick Ethernet, right? Now, what is this 10 base 2? Second type. 10 base 2 means what? Thin Ethernet. We can call as cheaper net. 10 base 2 means what? What is the exact length of that Ethernet is 185 meter only, right? So 10 Mbps speed, baseband means digital to digital communication, and 185 meter is a speed, right? So cable much thinner and more flexible, right? So this cable is much thinner and more flexible. So many times it will use whenever we don't want that much big network. At that time we are using this, right? Because the size is very small, 185 meter only. But it's okay, no, whenever we require more, means more quality and less quantity, at that time we are using this thin Ethernet. So it is a less expensive, as well as high level of attenuation is there. What is attenuation? You all know, right? Whenever our signal lose the power or energy, at that time attenuation is there. So for that we are using so many other devices, right, like repeater, right? So so that we can improve the energy of our signal. So it is less expensive. For small internet or small network, we are using this 10 base 2. Now what is third one? 10 base T. 10 base T means what? Twisted pair Ethernet. As the T, whenever during this Ethernet we mention T, then it is simply a twisted pair Ethernet. So I already told that in basic we are using bus topology, but in this higher version we are using star topology, right? So physical level star topology is used. Now if any collision happens, then hub can easily manage it, right? Why we are using star topology in this twisted pair only? Because in previous one our capacity is not that much, so with bus topology also we can manage, but here speed is more, so that's why we have to use some different topology. So that's why we are using star topology over here. Maximum length is 100 meter only, but quality is good whenever we are using twisted pair or optical fiber as a cable. It is minimize the effect of attenuation, right? 100 meter is there, but still attenuation is less because speed is more, or I can say energy of my signal is more. Now next one is 10 base F. As the name suggests, F means what? Fiber Ethernet. So whenever we are dealing with this F symbol, then it is a fiber Ethernet. So 10 Mbps baseband as well as fiber Ethernet, or we can say optical fiber, we'll use as a part of cable, right? And use star topology to connect the station to the hub, right? So this four was main type of, or main implementation type of our standard Ethernet. Now before we will start with fast Ethernet, gigabyte or 10 gigabyte Ethernet, what kind of changes is required in our standard Ethernet? So can we can improve our Ethernet topology or Ethernet network, right? So some basic changes is required in our standard Ethernet. After that, they'll start with fast gigabit, 10 gigabit Ethernet. So basic changes is, first one is bridge Ethernet. Means rather than connecting to Ethernet network with only a hub, we can connect it with bridge also. Why bridge? Because bridge can reduce the collision domain. Bridge is having somewhat memory, so it will work somewhat efficiently as compared to normal hub, right? So it will filter something or it will analyze something and then forward. So collision domain is reduced whenever we are using this bridge. So connection via bridges raise the bandwidth and separate the collision domain, right? So bandwidth also raised as well as separation of collision domain. So it is useful if we use bridged Ethernet. Second thing, switched Ethernet. If we use switch also, then also it's fine, because switch is also having some buffer also and some smart device. So switch is also fine if we use. Third one is full duplex Ethernet. So till now we are dealing with only half duplex, means at a time station can only send or only receive, but we can also use a full duplex Ethernet. And whenever we are using switched Ethernet, at that time two link are there. First one is for transmission, second one is for receive. Right, so it is useful for us so that we can increase the speed of our transmission. So switched Ethernet to full duplex switched Ethernet, right? So it full duplex, what it will do, it will increase the capacity by 10 to 20 Mbps. So before going to fast Ethernet, we have to change this kind of thing in our Ethernet. So it will be helpful for us to increase the efficiency, right? Now, what is the switch Ethernet? I already discussed. No need of CSMSEA because two separate paths are there. CSMSEA we will use for collision detection or collision avoidance, right? So here two separate paths are there. One switch, one node, one transmission line is there. Second one is receiver line is there, right? So it is easy for us to avoid the collision whenever we are dealing with switched Ethernet. And last change we have to do is MAC control layer. Means connectionless MAC sublayer we have to use. Till now we were mostly dealing with LLC only, but MAC layer is also useful. So flow and error control in full duplex switch network is there, right? So for that new sublayer use, that is MAC control layer. So we can use, if we use MAC layer, then also it's fine, right? So for that, we are using MAC address rather than LLC address, and some of the other changes we have to do. So I hope today's topic is clear to you. From next class, we will start with fast Ethernet. Thank you.